Namaskar. Uh, Good afternoon, everyone. Good afternoon, our today's resource person, Dr. K.R. Biswanathan, Dr. Nima Doma Lama, and Wing Commandant Prafullo Rao. And good afternoon, all the participants. Good afternoon, all the viewers who are watching this event live in our Science Center Facebook. I, on behalf of Kalimpong Science Center, welcome all of you in this digital platform. The topic of this webinar is how to use a cell phone app to report a landslide occurrence. This webinar is organizing by Kalimpong Science Center in association with SavTheHills, an NGO working on disaster management in Darjeeling Sikkim Himalayas. In this digital platform, here with us three specialists from different fields of science and technology. Dr. K.R. Biswanathan is an international specialist on climate change who works with Practical Action UK, an international charity which works over 30 countries in Latin, South America, West East Africa, and South Asia. He was a major in the army before leaving to pursue a diverse career where he worked with the Swiss Development Agency and Government of India. He has authored numerous papers on climate change and environmental issues. Welcome, Dr. Biswanathan, sir. We have another speaker, Dr. Nima Doma Lama. She's an associate professor in Siliguri College. She's also deeply concerned about environmental issues of the Himalayas. Welcome, madam, in this digital platform. And we have Wing Commandant Prafullo Rao, retired. He's from Kalimpong and a founding president of Save the Hills, an NGO working on disaster management in Darjeeling, Sikkim Himalayas. Welcome all of you in this digital platform. Now,
Thank you so very much, Dr. B.B. Gurung, and thank you all the guests. I think many of them are young speakers, young students who have joined. I will share my screen now and begin the presentation about how to use a cell phone app to report a landslide occurrence. I would like to thank Dr. B.B. Gurung for giving us this opportunity to talk about such a vital issue. The way I'm going to go about this is that after my brief introduction, I will hand over the stage to Dr. Nima Doma Lama. She is Associate Professor Geography in Siliguri College and the right person to talk about landslides. She will give a very basic level type of understanding about landslides, what they are, what are they caused by, and what types of landslides are there, and so on. So that would be about 10 to 15 minute talk by Dr. Nima Doma Lama, a brief introduction into landslides. Thereafter, she will hand over the stage back to me. I will then give you a rundown on the landslide tracker, which is being used, and what is the whole purpose of this presentation and webinar. After completing that, I will hand over the mic to Dr. K.R. Vishwanathan, who is my colleague in Project Landslip, and he will talk about Project Landslip, which, okay, I'll leave that to Vish to talk about, and he'll talk about the paper version. So having that would be our session today, and if we have time, we will go in for a question and answer session. I have a meeting lined up at 4 o'clock, so that is the only thing which may stop it. So, right. I am speaking right now from Kalimpong. Kalimpong is right next to Darjeeling. We were a part of Darjeeling district. Now we are a different part of different district altogether. And this is where we are. And I call our place a unique location. I hope you are still hearing me and you are able to see my screen, audience.
Yes, sir.
Thank you. So if you put your compass right there above at the somewhere in the middle of China and draw a circle, the Himalayan arc forms almost a perfect circle, as you can see. And we in Darjeeling, Kalimpong area, Sikkim area, We are located at the southernmost tip of that arc. And being so, we are uniquely placed. We are about 607 kilometers from the Bay of Bengal. And Kanchenjunga, the aerial distance from my home is about 57 kilometers, which is less than the road distance to Siliguri. So that's where we are. We are definitely in the direct path of the southwest monsoons whenever they start up, and our rainfall is around 4,000 millimeters. That is approximately 3 times the national average. We are not certainly the heaviest area where the rainfall comes. In the Western Ghats, there are many places which are very, very uh, rainy also. But when we think about the fact that these are the youngest mountains, the Western Ghats are comparatively much older, that brings about a different type of connotation. Also, the Bay of Bengal brews some of the deadliest cyclones in the world, and the most fatalities due to cyclones have been in our region. And we do not require cyclones only. We can have tiny, much less storms like a low pressure. Everything that happens in the Bay of Bengal will definitely affect us here in Kalimpong and in the Himalayas. We also have now rainfall patterns which are changing and a population which is growing rapidly all along the Himalayas. So all these factors are there, which makes our place particularly unique. And having said that, these are two maps which are not mine. The one on the left-hand side is the GSI map. The blue dot above is where we have our highest landslide areas, and that is where we live. Of course, due to the high rainfall, the human intervention in the mountains, etc., the highest landslide areas in the country, as per the GSI, is this region, along with other places, of course. And the one on the right-hand side is the seismic hazard map, where we are on zone 4. Zone 4, technically, as I keep saying, and this is not my saying, but a senior seismologist who has told me this, with zone 4, with the landslides, with the earthquake events which have occurred. But if we are to think about the earthquakes which are about to occur, then perhaps we would be in zone 5, not zone 4. So what we are is in the crosshairs of a multi-hazard scenario, and we've experienced this in our own life just in 2011, where the Sikkim earthquake triggered numerous landslides in North Sikkim. So one hazard can trigger another hazard. That is what we call a multi-hazard scenario. So having lived in this area, I will mainly concentrate on the hydrological events, earthquake being a totally different ball game altogether, where we hardly get any notice. But here in the hydrological events, this is what the rainfall seasons are. We have the winter, pre-monsoon, monsoon, and the post-monsoon seasons, and the rainfall for each month is given there. So we just crossed July, where we had our normal rainfall is 615 millimeters, 615 millimeters, 0.8. And we have just entered August. Our rainfall in August is 495.2. But as per today's report, the rainfall in August and September in the northeastern region is likely to be in excess of this, whereas in the northwest areas, they are slightly less expected. So this is the rainfall pattern as per the India Meteorological Department. What I would like to tell you is that the World Bank has said this: the Himalaya has almost twice as many hydrological extreme events as the Ganges Plain or the Tibetan Plateau. So that is what the dangers are, and there are increasing trends in precipitation extremes in Nepal, Bhutan, and in our area also. Having said that, this is the cloud picture which occurred just not even a week back, 29th of July, this is what exactly was there in our region. And I'm not sure whether this rainfall occurred in other parts of North Bengal, etc. It certainly did. It was a very, very selective type of rainfall. But in Kalimpong, we had tremendous amount of rainfall. That means from 12 o'clock till about 8:15. That was when I mapped this clouding. We had already had 98 millimeters of rain, whereas Darjeeling only had 20 millimeters and Gangtok had nothing. So this was a very selective type of specific type of rainfall, which occurs due to something like the clouding because of the cumulonimbus clouds moving. And you can see that low pressure where it is located. It is located here. It was just a small low pressure, which was not supposed to be giving us so much of rainfall, but it stayed hung around in this area for quite some time. And thereafter, the winds were such which were moving from the Bay of Bengal and bringing in a lot of moisture and clouding over us. We are here in Kalimpong, and the type of rain that happened was amazing. What I'd like to tell you here is I'd like to tell you that landslides are caused by the intensity of rainfall. If I were to explain this a little further, you see, if you have a bucket of water and you pour it, okay, onto a small model, a sand model, supposing you pour that bucket of water over a period of 1 month, okay, perhaps that sand hill or sand mountain will stay as it is because you're pouring that one bucket of water, maybe 20 liters, over a period of 1 month, right? So the amount of water is 20 liters. You're pouring it over a period of 1 month. The hill will perhaps stay. But if you pour that water within 2 minutes or maybe 30 seconds, that hill will collapse. The amount of water is still 20 liters. The intensity has increased in the second case. So in this particular case, the rainfall intensity is what we are bothered about. And this is what the graph said. I have a automatic weather station here, and this is from the automatic weather station. If you have a look, we had small amount of rainfall early in the morning. Then the rainfall started on the 29th in real earnest at around midday, somewhere here. Then it continued raining. And if you were to see this here at that side, the rainfall here is 80 millimeters per hour. Okay. And if you imagine this, if it is raining very, very hard at your place, most probably it'll be raining at around 80 millimeters per hour. That's very hard, heavy rainfall. Okay. But in Kalimpong, what happened was that as the night grew, as it became night, and at about 6 o'clock, the rainfall started increasing. Midnight, around, say somewhere around close to midnight, 9 o'clock, 10 o'clock, etc., the rainfall crossed 100 millimeters per hour. And in this area, for about 2 hours, we had 100 rainfall intensities, clocking more than 100 millimeters per hour for almost a sustained period. Peak rainfall intensities during that time was 167 millimeters per hour. So what happened was that in that particular small span, we had something like 37.67% of our monthly rainfall coming down within 13 hours. So that is the problem with the rainfall these days. That intensities tend to go up so fast and they remain there. And that is what causes the landslide problem. So what happened was the rainfall stopped at around 2 o'clock. Thank God for that. But the next day we had plenty of landslides. So this is what the newspaper read that day. Next day, that 2 died and 3 were missing, and there were numerous other fatalities, numerous other landslides, many more landslides. And this is on the right hand side of the picture, you see a landslide which occurred in my area, which is Balukop, and it destroyed farmland. It also destroyed a cowshed and a piggery. And to people who are living in the Basti, the village areas, that is dear money, livelihoods going down the drain. So now to tell us more about landslides and what they are, how they are caused, etc., I will hand over the mic to my colleague, Dr. Nima Domalama. Nima, over to you. I'm stopping sharing now.
Thank you, sir. A very good afternoon to all our young participants who are with us today. Okay, so like initially when I was invited to participate in this webinar, I knew that I was going to face some challenges, okay, and the challenges are basically twofold. First, I was asked to give a basic introductory lecture on landslides to students basically from class 8 upwards, okay, 8, 9, 10. And also at the same time, we'd have a mixed group. Probably we would have some professionals as well as some teachers. And so like it's going to be primarily targeted at young students, okay, but I'll try to make it basic and simple, but at the same time I should not be compromising on quality. That was one thing. And another thing is this, the identification of landslides that we are doing in the field. Okay, that is basically to help the young students to, when they are using the app, okay, there is a whole section where they have to identify what type of landslide it is. So I hope this lecture will be helping the students when they're using the app in the field. Okay, so that is why that's the way I've framed it. The second and the most daunting challenge was undoubtedly the time that Wing Commander Rao has given me. Okay, so sir had asked me to speak for 10 minutes, but after much persuasion, sir has kindly, but rather reluctantly, increased the time to 15 minutes. And any geography teacher who is present here will understand, okay, the vast topic like landslide, and just summarizing it in 15 minutes is going to be very, very difficult. Okay, but to help me overcome this challenge, I had my team from Siliguri College, Geography, my students who are now in NBU, and my colleague, okay, Dipankar Das, Professor Dipankar Das, and with their help, we've been able to make a 3D model, okay, but the only thing is we wanted to put it online, like live, and show the model, but we had some problems with the recording and uploading the video. So what I'm going to do is I've taken screenshots and close range shots, and with the help of that, we hope the students will benefit from this. Okay, so now I'll be sharing my screen. Is it visible?
Yes, ma'am.
Okay.
Yes,
So the topic today is identification of landslides in the field, primarily for young students who would be going to the field with the app, using the app. Okay, so I would be failing in my duties if I did not first and foremost introduce my team Geo from Siliguri College. Okay, so to my left, uh, I have Professor Tuhin and Professor Dipankar Das. Okay, they are assistant professors, and I have Sudeep, Pradeep, and Ranadeep. Okay, who are very who came forward and helped me make this 3D model that would help the students understand what they will be seeing when they go out to the field. Okay, so let me start at the basics. Okay, starting at the basic, I'd like to start with one question. A landslide, is it a hazard or is it a geomorphic process? To answer this question, we first need to understand what are the basic causes or what triggers a landslide. Okay, and let's start at the definition. Landslide, which is also called landslip sometimes, it is the downward movement of a mass of rock, debris, earth, or soil, and it occurs when the gravitational and other shear stresses within the slope exceeds the shear strength of the materials that form the slope. Okay, now you can have different types of shear stresses, okay, that make that trigger a landslide. So basically, when you're looking at the long-term stresses, we have I've taken all this I'm taking, okay, is in the context of Darjeeling Himalaya. I will be using the geologically often used term Darjeeling Himalaya to include both Kalimpong and Darjeeling district, Eastern Himalaya for Darjeeling, Kalimpong, and Sikkim. Okay, so Okay, we're talking about the long-term and the short-term stresses that we have. Now, regarding the long-term stresses, we find that there is the over-steepening of the base of the slope. Okay, now this can be because of a natural erosion. Okay, like the T-star. Okay, especially when you are coming along NH10, you find that there is the undercutting of the banks of the T-star. So what this does is, because there is this basal erosion, okay, the road that is just on top, it becomes an overhang, and ultimately when the weight is no longer being able to be held by the underlying rocks, it just collapses. And that is why we have the major landslides out there in Likuvir, in the 29 mile and all that. Okay, so this is one reason that we have. We also have anthropogenic interferences like mining, blasting. Okay, the railroad construction and the mines and all, they do a lot of blasting. So when you have already the fragile hills are there, and then there is blasting, we find that there is stress that is exerted upon the slope. Okay, there is the loading of the slope again. That can be because of inflow of water, if there is huge amount of precipitation and it comes. Okay, or the hydrological reasons we have, because when the rivers and all, when they're flowing, okay, the volume of water, when it increases suddenly, when there is excessive volume of water, it leads to the loading of slope. Again, another thing that we have is the rise in groundwater table. Okay, a very interesting study was made in 2016 by Biswas and Pal, and they have considered the presence of the Mirik Lake as a landslide inducing factor. They are considering the lake itself to be a landslide inducing factor, basically because the continuous percolation of water through the pore spaces, the joints and the cracks, okay, in the Mirik Lake is enhanced by intense rain during the monsoons, as a result of which it lubricates the parent rocks and there is consequent reduction in the resistance, as a result of which occurrences of landslides is significant not only in Mirik but also in the surrounding areas of Tingling and Saurani. So the immediate short-term stresses that we have are earthquakes, like the Nepal and Sikkim earthquake. Okay, when we had the Nepal and Sikkim earthquake, we found that there was an incidental increase in the number of landslides in the Darjeeling and Eastern Himalayas. Okay, then we have intense rainfall events, which also precipitate landslide events. I'd like to call attention to the 1968 disaster, okay, which is the one disaster which is truly a disaster, because basically the landslide episodes we have in our region, they are basically small instances where only a part of a slope is affected, or one area is affected, or one town, that one region, one small area is affected. But in 1968, okay, we had this huge area where we had nearly 20,000 landslides were said to have occurred during this period. Okay, and this was during 2nd to 5th of October, when 1,000 millimeter or more of rainfall was recorded in a period of 52 hours. Okay, and this was the time when the famous Ambutia landslide that was also initiated during this period. And we've had instances like Cyclone Isla, and we have in between, we have the cloudburst events and all. And Kalimpong just recently on 29th and 30th of July, we had an incident where we had huge amount of rainfall within 24 hours that precipitated a large number of landslides. So the second thing that you have is the accumulation of debris on the slope. Okay, now this happens is because like there is something that is called the angle of repose, which is also known as the critical angle of repose. That is the steepest angle of descent or dip that is relative to the horizontal plane, okay, on which a material can stay without slumping. Okay, the dip can range from 0 degrees, that is a horizontal plane, to 90 degrees. Okay, that is your right angle. Okay, and we know that the steeper the slope, there will be less safety in terms of landslides. Another reason we find is the lateral, when we remove the lateral support, suppose there is a slope, and to construct a road or a railway, okay, you just cut through that slope. What we are doing is actually we are cutting through removing the support that you have laterally. So as a result of which, what happens is a mass of material just slumps down, or there's a landslide that takes place. Okay, so these are what we find. These are the examples which are very, very common that we find in the Himalayan region, in Darjeeling Himalayan region. Okay, so we have a very good example of this type of removal of lateral support along the Pagla Jhora region, okay, which every year there, we always have landslides that take place out there, okay. And with the help of this 3D model that was made by my students, we hope the students, young students, will be able to identify the different landslips in the field, okay, and they can go to the field, and when they associate it with this model, they'll be able to identify the different types of landslides that we have. Okay, and this the Landslide Tracker app, it was designed by Amrita University for the landslip project. Okay, Major Vish will be talking more about that. Now, when you come to the major triggers of landslides in Darjeeling Himalaya, okay, geology is undoubtedly a major concern, okay, because geologically a significant portion of the Darjeeling Himalaya is composed of highly weathered chlorite schists, phyllites, and mica schists that belong to the Gurubathan formation of the Darling series. Okay, and especially when you're talking in terms of Kalimpong district, we find that 82% of the region, it lies between 804 to 1440 meters. Okay, that falls in this zone of the Darling series. Okay, now these rocks are very, very fragile. Okay, and they consist primarily of mica schists and phyllites, and we know that mica schists are very, very weak rocks. Okay, and most of the landslides that occur have taken place in regions that are composed of mica schist. So this is I've taken a sample of a mica schist. From here we can see the schist is broken up into very thin flaky plates. Okay, and mica is a very, very soft mineral. So what happens is when water comes during the monsoon, okay, and it is the mica schist, it just absorbs a lot of water, and the mica, it tends to expand, okay, and then already it is very weak and fragile. I can just break it. It is a very, very soft rock. I can just break it with my hands, and when it becomes completely loaded with water, what happens is it becomes very, very soft and it breaks. So it just crumbles like a cake, okay, or a cookie when you put it in water. So it's so fragile. Okay, so this is one reason why we find that geology is so important. The second thing is we've had intense rainfall and precipitation, okay, that are the major triggers of landslide along with earthquakes. Okay, now in terms of rainfall, okay, the importance of rainfall as a trigger, it can never be overemphasized. In the Darjeeling Himalaya, we find that geologists have identified two notable what is called precipitation thresholds. Okay, now what is a precipitation threshold? Okay, it is the cumulative precipitation amount for a given time period and soil conditions, which will generate critical runoffs enough to provoke a landslide. Okay, so if you cross this threshold, then the slope becomes very, very vulnerable to landslides. Okay, and we have two critical thresholds. One is the seasonal threshold, and the other is your threshold within a short period, either 24 hours or 3 days. Okay, so that is for a shorter period. Okay, so now what we find is that Gabet et al. In the Nepal Himalaya in 2004, they have identified 860 plus millimeters to be the precipitation threshold during the monsoon. For the entire monsoon season, if an area is exceeding 860 millimeters or more, okay, then that area, that region becomes susceptible to landslides. Okay, but in recent times, with the frequency and intensity of cloudbursts, okay, we are going far beyond this figure. So that is something we need to worry about. And when you come to the shorter term of precipitation thresholds, okay, we've had incidences of cloudbursts. Okay, we've had incidences like Cyclone Isla, okay, or just a week back on the 29th and 30th of July that we had in Kalimpong. We find that the precipitation intensity, it easily exceeds 135 to 145 millimeters in 1 hour. Okay, and Kalimpong that day, Wing Commander Rao has uploaded at one instance, at one time early in the morning around 2 a.m. Okay, we even clocked, I think, 165 plus, okay, millimeters in 1 hour. Okay, that was the intensity with that we had. And it has been seen that even when we exceed 50 millimeters per hour, just 50 millimeters per hour, landslides have been known to be triggered in our region. Okay, so this is why it becomes very important that we understand. The next thing that we have is the earthquake. Okay, the earthquakes that we have, like I said, the Nepal and Sikkim earthquakes have precipitated landslides in our region. Okay, and we have hydrological conditions like the flow of the Teesta, a huge mighty river like the Teesta. Okay, with anthropogenic interferences that we are building the low dams, we are building the rail project on top of that, the roads. Okay, so what we are doing is we are trying to control and harness a very very powerful river, and we are actually interfering with the fluvial regime. Now, this will obviously have a lot of consequences that will not be good for the humankind. Okay, and you had a very good study in 2018 that was done by Dixit and Satyam, where they noted that often the first order streams of the Teesta, the Balasan, and the Mahanadi in our regions did disappear. They start at the slope. Okay, they start at the slope and then they disappear. Okay, so this is actually the reason that we have. Okay, then you have the anthropogenic influences that everyone knows.
You have to go much forward. Yeah.
Okay,
It's
unscientific
visible.
land use. Okay, building on steep slopes, flouting the clogging of the joras and all. So these are the anthropogenic influences that we have. Now, when you go to identify landslides in the field, okay, we find that landslides are classified on in a variety of ways, on the material that is involved, the movement, the velocity, the activity, and all. So basically, what we are doing is we are going to take three classifications. First is on the basis of materials that we have. Okay, so when we have 80% or more of the particles that are smaller than 2 millimeter, okay, we consider that to be an earth flow. Okay, when 80% or more of the particles are smaller than 0.06 millimeters, we consider that to be a mudslide or a mud flow. Okay, and debris flow or debris slide would consist of a proportion of coarse materials that are 20 to 80%, which are larger than 2 millimeter, and the remainder are less than 2 millimeters. And all the rock debris, rock slide and all, that would consist of gravels and stones and boulders, which are of much larger particles. So when you hear of any term, okay, that says debris flow, okay, then you have to understand that it is essentially unconsolidated coarse material. Okay, so that way we classify the materials. On the basis of velocity and the percentage of water, when you look at the sediment flows, we have sediments which go very slow, like solifluction and creep, and we have debris avalanche and mud flows which grow very fast, okay, nearly 400 kilometers per hour, whereas your creep would be only 1 centimeter per year. Okay, and the difference in terms of water is if it is within 0 to 20% the water content, then it would be creep, earth flow, or grain flow, or a debris avalanche. But if the percentage of water is more, okay, then you would have solifluction or debris flow, mud flow, or a slurry flow. Okay, so this is how we actually classify on the basis of water content. Now, on the basis of movement, okay, we have three very simple types of movements: the fall, the slide, and the flow. In the field, okay, so what is a fall? If the material drops vertically through the air or nearly vertically, that is a fall, a rock fall. Okay, a slide is if the vertical material moves along a sloping surface without internal motion within the mass, and a flow is if there is internal motion, probably because of the influence of some fluid like water, which will give rise to liquefaction. But in the field, it is not so simple, and we find that many slow failure, it involves 2 or 3 types of these motions together. Okay, so then you have to go and you have to have a greater understanding. Okay, so to overcome this, Burns has given a schematic classification in 1978, okay, where he has taken the different types of material, like the rock, the debris, the earth, okay, and the different flows that you have. And he has taken the type of movement that each of these materials would make. On the basis of this, he has identified that the types of movement would consist of falls, topples, then slides, which are again divided into rotational or translational. Then we have your lateral slides, the flows, and finally you have the complex slides. Okay, so a fall, when you look at a fall, a rock fall, okay, that means this is a rock. We already said huge boulders, stones, and pebbles that fall vertically would be a rock fall. So for this, what you need is you need a steep face like a cliff. This is a cliff. So you just imagine, okay, if it is 90-degree, nearly 90-degree, and if a boulder were to fall from the top out here, it would fall vertically. Okay, so it would make a free fall. Okay, so that is the first type of rock fall that you have. Now, when you have a slightly inclined slope, okay, not a gentle, but an inclined slope between 45 to 60 degrees, what would happen to a rock falling from the top? It would not fall vertically, but it would come, it would bounce down, then again it would bounce, and again it would bounce and come down. So that type of a bouncing movement would also be considered a rock fall. Okay, and finally, when you have a gentle slope, okay, here we made a gentle slope, and if a rock were to fall along this gentle slope, what you would have is the rock would it would roll down. Okay, it would glide down this gentle slope. So that would still be a rock fall. So these are the three ways in which a rock fall takes place depending on the inclination of the slope. The next thing that you have is a rock topple. Okay, now rock toppling, it takes place when there is forward rotational movement of a unit or a number of units about just on a pivotal point. And usually that pivotal point is at the base of there. Okay, so you have these, especially in the Sandakpur area and all, you have where there's a lot of undercutting because of the development of tourism. Okay, now the trekking route is no longer trekking route. It has become a road. Okay, you have a lot of cars going. So to build the roads and all, they undercut a lot of the area. Okay, so as a result of which, when you have a cold regime like Sandakpur, okay, and you have the huge boulders, which are consistently subject to your freeze thaw motion, okay, the cracks and the jointings, they become very huge. Now when it becomes the cracks and jointings become very huge, they start widening, and then slowly what happens is it will topple over. Okay, so it will topple over, and the pivot will be at the base or much lower. Okay, so it will be under the influence because it's been pushed by the unit that is adjacent to it, or it will be pushed because of this water that has accumulated within. Okay, or it can be because under the influence of gravity. Another case of toppling we can see is along the banks of the Teesta, okay, where again, because of the undercutting by the river, we find, and as the river undercuts and the joints and all are exposed, the water enters, and then there is the pivotal, and there's the forward movement of huge blocks, okay, at the base, that is known as toppling. So you have a case of toppling even in the lower areas. Now, the next that we come to is the slide. Okay, now a slide can be of two types. Okay, the first would be a planar or translational slide, and the second type would be a rotational slide, which is also known as a slump. A planar slide, okay, would require that the whole material that is flowing down would be relatively on a roughly planar surface, and there will be very little or no backward tilting, okay, of the materials that are being moved downhill. But on the other hand, okay, if you look at the slumping or a rotational slide, we find that the surface of rupture, it is concave, okay, concave upwards, and then there is backward tilting. There is a rotational motion. The axis will be almost parallel to the ground, okay, or it will be transverse across the slide. Okay, so along this axis, there will be a backward rotational movement and the material will slump down. So this is known as a slump. Okay, a good example of your planar or translational slide would be a block glide, okay, where you have the entire section of the rock that is moving downhill, okay, and it consists of relatively a coherent unit, okay, and this would essentially require a low friction surface, okay, like a wet clay surface or something, that would accelerate the movement of a huge area of rock moving downhill. Okay, now when you come to the debris flow, okay, this is a mass of predominantly inconsolidated and incoherent soil and rock fragments that come down, and usually we find the presence of a hummocky deposit at the base. Then when you look at the morphology of a slump, we find that it has a huge surface of rupture that is concave. Okay, then you have your different scarps out here. So we have tried to show the different scarps that you have. Okay, and this is known as the toe of the slide. This is the crown or the head of the scarp, and then you have a number of minor scarps. Then you have a number of, if you go to the landslide and if you just walk on it, you'll find there are a number of ridges and cracks along this scarp. Okay, so what happens is the whole area, it tends to subside because this whole area is coming down. Okay, this is very clearly seen in the Paglajora area. Okay, so you find certain characteristic signs that tell us that slumping is taking place in an area. For example, if the electricity lines are slumping, okay, or if they are the wires have become extremely tight, if they are tilted, if there is broken retaining walls, okay, so the retaining wall you have out here, it was a straight retaining wall, but because of the slumping it has broken down. If you find that the road itself, it is going up and down, okay, undulating, like especially near 8th Mile in Kalimpong, okay, you find this type of slumping that is very, very marked, where the road itself, it tends to go down. Okay, so these are signs that the area is undergoing slumping. Okay, and then you have also what is known as deranged forests or dead trees. Okay, that was, that area had some trees, but suddenly the trees, they start dying or they become weak. Okay, that is because the water that was present here is suddenly lost. Okay, when the groundwater table, it moves down. Okay, so the trees are not able to get, and you have a lot of dead trees that occur, that come down here. Then you have the lateral spread, the flows and complex landslides. Okay, now when you talk of the lateral spreads, now these are very, very distinct. What you have in the foreground out here, this is a lateral spread. Now this is distinct because it happens on very gentle slope and especially on flat terrain. And this is especially due to liquefaction in the case of an earthquake. When it takes place, when the loose saturated cohesion-less sediments and silts, when they are completely transformed and then they start moving in a liquefied manner. Okay, so that becomes a lateral spread. When you're talking of the flows, we have that these are the downslope movement of materials in the form of fluid. Okay, and generally we see that they make a funnel shape. Out here we have the mud flow, it makes a funnel shape where the mud flow, it stops moving. Okay, so when you have a combination of all these factors, it can be a combination of slumping along with the debris flow, okay, that you find in Paglachora area or even in Ambutia. We find that these are not typically one type of landslide. So these are what we call complex, the last type of landslides that we call the complex landslides. Okay, another thing that we see is the soil creep, which is your imperceptibly slow, steady downhill movement of slow forming materials that take place. Okay, now again, we find that the movement is generally caused by shear stresses that produce permanent deformation, but it does not produce any shear failure. Okay, and it becomes very easy to understand when you are going to the field. You can identify, okay, you cannot see the movement because these are very, very slow moving, only around 1 millimeter per year, okay, or 1 centimeter per year. So when it is moving, you cannot see that it is moving, but there are signs, okay, like the tilting of your electric poles, your fences that have tilted. If we go to the cemetery in Darjeeling, just below, above your government college, around government college, below shrubbery, you find that some of the headstones, okay, in the cemetery, they have become tilted. Okay, and the trees also, they tend to have these type of curves, they grow up in a curved manner. So these are signs that tell us that these slopes are slowly moving. Okay, and it landslide could be imminent in these areas, so we have to be better prepared for this. Okay, so this will help us identify. Now we have some mitigation measures for landslides. Okay, most of this would primarily be for the government, the administration, and research agencies. Okay, so I would my appeal today to the students is, when you grow up, you can look at all these different mitigation measures. But at present, what would be your contribution to help mitigation in Darjeeling Himalaya? Okay, our appeal to you is, if you could just spare some time to go to the field, okay, to interact with your friends and to spread the landslide tracker app, so that we can amplify the landslide database, okay, that project landslip is making and GSI is making, so that we can make our hills a safer place. Okay, and it is very,
And
it is very evident that Darjeeling Himalaya has never been, and it will never be, free from the ubiquity of weak geology, slope instability, intense precipitation, or frequent seismicity, soil erosion, etc. So, to answer my primary question that I asked in the beginning, okay, we know that the mountain slopes of Darjeeling Himalaya, they are governed by the laws of gravity, which is combined by the lubricant forces like excessive water and precipitation, unstable slopes, okay, which cause devastations and losses of life and property. So essentially, a landslide is a hazard from the societal point of view. But from a geomorphological viewpoint, a landslide is an important geomorphic process for hill slope development and evolution. Okay, so this is something that we just have to live with it. It'll always take place as long as there is gravity, as long as there is rainfall, as long as the slopes are steep. We will have to learn to live with the landslides. But at the same time, we can take measures. Okay, how can we make ourselves more safe? Okay, so the common refrain that I hear from most of my young students in this regard is, ma'am, how can I make a change by myself? How can I do it myself? How can this change come just by myself? Okay, now today we need to go no further. Okay, we have two very eminent role models before us, okay, who have made the mitigation of environmental hazards their mission and vision in life. We have Dr. Vishwanathan and we have Wing Commander Rao, who have made a mission and vision of their life to overcome these hazards. Okay, learn from the examples that are being said. Now, I can give you one inspiration. Okay, a single decision that was taken by Wing Commander Praful Rao after the devastating rainfall episodes of 2007 that prompted him to get up one morning, okay, to go around and start the STH blog, which he termed the Visions of Hell. Okay, and from there, Save the Hills, it started. And today, both Save the Hills and Hazard Alerts are indisputable database for documentation of landslide and precipitation events. And having worked closely with stalwarts like Professor Petley, Professor Andrew Rumba, Professor Bruce Malamud, Save the Hills today has been instrumental in bringing the local and often neglected landslide problems of our hills to international forums. So we are also privileged that today a project like Project Landslip has chosen Darjeeling Himalaya as a pilot project. Okay, and if this project is successful, we are going to benefit, the residents of the Darjeeling Hills. We are the ones who are going to benefit, along with all the hilly areas of the world. They are going to benefit. So I appeal to all our young students to come forward and use the app, and it will be your love, your service, and your dedication to your beloved hills that you have, because whether we opt for a safe and stable queen of hills or a Darjeeling Himalaya that is transformed into visions of hell, the ultimate choice is ours. Thank you.
Thank you, Dr. Lama. Thank you for making a very complex subject more simple than I thought it would be. Thank you so much. Now to go ahead with the rest of the presentation. I will now continue my presentation. Okay. Is the screen visible?
Yes, sir, it is visible, sir.
Is the screen visible? I can't hear. Can one person?
Yes, sir, it is visible, sir.
Right. I'm continuing. I'll have to run down the thing rather quickly because I've got another meeting waiting. Okay. So the point is that if we have to report a landslide, what are the important factors? I mean, we tend to say, okay, it's a big landslide, or it rained a lot, or it occurred somewhere in some tea garden, okay, or it occurred in Sindebung. But that doesn't make any sense. If this data has to be used properly, then the data has to be reported properly. So then only we can get scientific minds working on this data. Otherwise, what happens is that we are giving information which is absolutely great for sensation, like the YouTube videos that are there, but they cannot be used. So in terms of reporting the landslides, what we have to do is we have to think of these points, which I've written down there. When did it occur? The date and time are important. And where did it occur? If you can give us coordinates, that's the best. Otherwise, you'll have to tell us, okay, it occurred 500 meters from that church in some basti. That will be better, okay? There is no point telling us that it occurred in Chari, some tea garden. Where? It doesn't make any... And what we have to do is we have to give the date and time quickly. Because what I've done this numerous times is that when we go there after a month, and ask people, when did this landslide occur? They will say, that time when there was a big rainfall, that time it occurred. No, it doesn't make any sense. Because if science has to correlate these factors, then it requires precise information, right? The next point that we want is a photograph. You don't just kindly take a mass of rocks or a slide with some house and give that to us as a photograph. Make the photograph meaningful in the sense that the photograph should have some sort of scale. It should tell us what that landslide has done. It should tell us, say for example, if you take a scooter passing a landslide, then we will at once come to know that, okay, the scooter has occurred at the roadside and it is the size of the scooter and the landslide we can relate. Okay, so that photograph, don't take any odd photograph with your cell phone, as you most probably will be using, and send us. Make the photograph meaningful so that we know what scale that landslide is, where it has occurred, how many people, how many houses it has damaged. All those things must be thought of while taking a photograph. If you can tell us the probable cause of the landslide. What I have come to know very often is that even the geological scientists, they refer to the local people. I've gone around with GSI people, scientists who say, Mr. Rao, I normally ask the village people, and they tell me what they know far better than I do, which is true. The rainfall details, again, don't tell us that it's rained very hard. If you can get a rainfall gauge, a manual rainfall gauge, we can give it to you. Give us your details. I will send you manual rainfall gauges, which you can use. Okay. Then the size of the landslide is important because we want to know how big it is, what damage it has done. So the size of the landslide, you can relate to, like in the app, it is given very, very well, that you may not be able to tell us in terms of meters, what is the size of the landslide, but you can certainly say that it is the size of a one-story building, or it is the size of a truck. It is the size of a three-story building. So that sort of information will be very, very useful for us. The next point is the type of landslide, which Dr. Nima has just gone through, whether it is a rock fall or whether it is a slide or whether it is a rotational slide or something. If you can give us that sort of information, it will be great. Then the next point is whether there were casualties and what sort of damage was there. If it was fatalities, then you have to tell us so many people died. Or if the houses were washed away, then you have to tell us so many houses were lost, right? And if you can, please tell us what are the remedial measures that we can take. Okay, then don't forget to add your name and details, right? So about the landslide tracker, I'm rushing through because I'm running short of time. The landslide tracker, which has been developed by a project group called Landslip. It it consists of people from India, the Geological Survey of India, scientists from there. It consists of the British Geological Survey. It consists of UK Met. That means the component which is akin to same like IMET-D. It consists of Practical Action. It consists of Amrita University. It consists of King's College London, and a whole lot of group of people who have worked on a project which is supposed to give landslide early warning to two places. One is Darjeeling, the other one is Nilgiris, and in the process, they have developed this app. The app itself, the software has been written by Amrita University. Therefore, you will have to download it from Amrita University. It is called Amrita University Landslide Tracker. But the project has been developed by the project Landslip. Okay, the aim being to standardize landslide reporting, because what happens is that, if I were to ask Sikkim government, how are they reporting landslides and how are they reporting in video Kalimpong 1, the two places will be reporting landslides differently. And certainly landslides will be reported differently in Nagaland or in Kashmir. But we have to report the landslides in a standardized, uniform manner, which is scientifically tenable. So that is the reason why this app has been developed. It is still undergoing constant review. Field trials have been carried out. I myself did a considerable amount of field trials in Darjeeling and Kalimpong. I have reported about 60 odd landslide, maybe more. It has 3 levels, but when you use the level now, you will be logging into level 1, which is the most preliminary and the basic level. For the time being, I think that is more than sufficient for us to use level 1. Okay, it does require internet, but you can also do and reporting on the offline mode, because if there's no internet, and I've used the app at very remote areas, I have gone on walking to very, very remote areas where there's hardly any internet. So there I've just taken a GPS reading, got the coordinates, and come back and taken a photograph maybe, and come back and filled it up offline. Okay. It is available in English, but there are other languages as well. I just recently gave a translation of the landslide terms to Amrita University, translated into Nepali. So Nepali is coming up, and many of the translation is from Google translation, so it may not be exactly accurate. But non-English versions are also available. It works in areas of poor connectivity, and if it doesn't, then you please fill up the details later. Just take the coordinates and take a photograph, right? Okay. So how do you do it? So the Landslide app, I hope many of you have downloaded the app. It's available from Google Play Store. You have to download the Landslide Tracker app from Google Play Store, and it's called Amrita Vishwa Vidya Peetham Communication. So once you download it, you just have to install it's installed on your mobile, and this is what you see. The Landslide Tracker, you have to sign up, and the sign up is something similar to any signing up, whether you're using Gmail or any other place where you sign up. You give your username, password, etc., etc. So simple. In fact, the app is so simple to use. Many of you watching this webinar or participating in this webinar are young people. You are used to apps, you are used to cell phones, and you will find this app a piece of cheesecake. It will be as simple as that. Okay, so don't get too confused about what I'm talking about. It is very, very simple to use. So next thing that you have is, when you have this screen, you will see this landslide tracker, and you have to sign in. You put your login name and your password, and then the next screen which comes up is this one with the landslide. This screen will come up on your cell phone. Okay, here you have to tick mark this thing at the bottom, which gives them the assurance that you have read the safety rules. That thing at the green tick mark, you have to check mark it, and then you can go forward. Okay, then now you have two places. One is the landslide on the left, and the rain on the right. Forget about the rain for the time being. you need not bother about that. We are only concerned about landslide. You just touch this on your cell phone. Just touch this with the landslide. Having clicked on the I have read the safety, etc., etc. Those three bars at the top left-hand corner, I will come to that a little later, right? And those two marks at the side also, I will come to a little later. Okay. I hope you're understanding me. Can I? Am I? I hope I'm not talking to a blank wall. Can you hear me?
Yes, sir.
Okay, great.
You are loud and clear, sir.
Okay, great. Okay, fine. Okay, so the next screen that will come up is this, that when you press on the landslides, you will come to this Google Earth picture. Okay, the app will automatically map where you are and show which position you are, and it'll give the coordinates at the top. The lat long will be there, and you can see on the screen now you have the purple in the location. So this is the first part of the app where you're looking at the app, and the location is now where you are. Okay, so all you have to do is here just look at the screen and check out that, okay, perhaps this is where I am. Okay, otherwise if you want to search for a place, you can put your search right up there where there's a search, and forget about this thing about rotation, etc. For the time being. You need not bother about that. Don't get confused about that. What you need to be bothered about is the next, the lower part of the thing. Do you know the exact occurrence? That is important, right? Do you know the exact occurrence? If you just touch that, you will get a drop-down menu which says, I know the exact occurrence. Okay. If you know the exact occurrence, then just touch that. Okay. When you touch that, a calendar will come up. That calendar will show you which date it is. Okay. So supposing it is August 3rd, then it will come up with showing August calendar and also July, and you can go back on the July. So just check mark the date when it occurred. Then the next thing will be the time. So if you know the time, you can also check mark the time, right? That is if you know the exact date. If you know the approximate date only, then you have to just touch the approximate date. Then the screen will turn to choose the approximate occurrence, right? Then it'll be in the last 3 days or last week or last month or last 1 year or maybe older than a year, right? So you can just touch that and that will be registered in your Landslide app. If you don't know where the occurrence is, you just touch that and the screen vanishes, right? So this screen is very, very simple to use, the first screen. Okay. Along with that, if you have a look at the top right-hand corner, you will see you can select several languages. You can try Nepali. I have not really gone into that sort of thing. I have been using the English version. The next red spot, of course, is where, again, the safety measures for reporting are there, right? What are the safety measures you should take? So that is the first screen. It's simple as that. Can I go to the next screen? Anybody answering me, please?
Yes, please. Yes, please.
Right. So if you see the purple one was on location, now you touch the images one, right? So now you have to record the image, right? So you can you can touch the images one, that will turn purple, and you will have the next screen which is coming up, which will be showing camera and gallery. You can now take a photograph of the thing if you want to use the camera, or if you've already got some photographs of that area, you can go to your gallery and choose the image from the gallery. Okay. The screen, as soon as you touch the camera, the screen will turn to photographs. Take the picture from a safe location. All those things will come up. You just have to click on OK. Just go down and touch OK. You will come to the next screen. Okay. Now I'm going to the next screen. So we've completed the image, the location. We've completed the image, right? You've taken a photo. You've got the coordinates. You got the place. You've also told what time, when did the landslide occur, etc. And you've taken a photograph of it, right? So now there are a couple of questions which you have to answer. Okay, that's the third one which is there. The questions. Now it talks about when did the landslide occur. Okay, or how did you know this? Okay, it talks about how did you know about the information. So you can say if you have seen it yourself, you're standing at the landslide site. You can say I observed it. Or somebody told you that, okay, there's a landslide there, you can say that. Social media these days, the the Facebook, etc., carry too much of news about this, and so on. So you just have to give that correct information, right? Question number one is, how did you know about this information, right? So the question number two is, just one second. Yeah, so that's it as far as the question number one is. There's only one question. There is only one question here as regards the occurrence date, occurrence data. Okay, that is, how do you know about this information? Like next question is landslide location, and there are two questions. It'll come to these questions which are here on the right hand side, which is again very simple. If the landslide has occurred near a road, please click on that. If it is next to a village, tea plantation, dense forest, sparse forest, next to a river, etc., you choose the correct place. So having gone through the information, how do you know about the information? Now you're answering, where did the landslide take place? Okay. The next question is, any other relevant information to describe the landslides. So now, if you are now looking at say, as it very frequently occurs, that all these ones near a road there in the second part, that the landslide has occurred 200 meters or 500 meters from me, if possible in a southeastern direction and across the river Tista. So that is the one for paragraph 2. I hope that is clear. Right, next. So the next thing is, again, we are still in the questions. We are going to the landslide type. This is what Dr. Nima covered about. So you have to write whether it was a rock, debris, earth, or you don't know what it is. Like most of the time, I am not too sure, frankly speaking, because landslides are complex. It is not, as Dr. Nima said, it may not be only one type of landslide. Okay, so you can choose whatever you want there, and if you can identify the landslide type, landslide material, then it will be wonderful if you can say so. Otherwise, you just click on I cannot say. Right? Like in the landslide size now, you have a choice whether it is small, medium, or large. Okay, and here I think the landslide app has got the relation of the landslide to buildings. So a small landslide would be 1-story building. A medium building will be 2 to 3 story. Medium-sized landslide would be a 2 to 3 story building. Much bigger than a 3-story building. So require that way. Okay? So it becomes very simple for you to answer these questions also. So the next question here is, okay. Okay, you will be asked in this landslide app many times, how did you know about this information? Okay, so if you don't have the time to fill up this, please leave it. You can answer this when you go back, if at all. Okay, and at any time you have a shortage of time, you might be in a rush, you might be walking home and you see a landslide and you want to get back, it might be raining. You just submit it here. You can submit the report and it will say, do you want to submit it, etc., etc. You just say yes, and you can fill up all the other gaps later. So it is not that you have to complete the entire reporting, that you have to, and then only submit it. You can submit. That's why that submit button is there in almost every page. So you can submit it at any point of time. Here, what triggered the next question is important. What triggered the landslide, right? So here, the trigger, you would most probably say it is because of heavy rain. Okay. Then there's a talk about what related to the rainfall. Was it still raining? What is the intensity in terms of drizzle, slightly raining, medium rain, heavy rainfall? Okay. How long did it rain? Half a day, whole day, 1 week, more than a week. Right? So that is what triggered the landslide. Okay. If it was triggered by earthquake or if it was triggered by some other thing, then you click on the correct thing. And if there is a place at the end where you can say what triggered it. Okay. And if you don't know, just say you don't know. Okay. And submit if you require to submit it. Right. Okay. So the next slide. Okay. What's happening? Oops, something's going wrong. Can you hear me?
Yes, sir.
Just 1 second. Something's going wrong. It had to go wrong somewhere. Okay. Is this the last one? No. Was it? Okay. Just 1 second. Okay. So we've gone through this. Yeah. So the next page is this, where after okay, there is something about what is endangered. I think there is a page which is somewhere missing. Okay, so there is a page here which talks about what was the damage done. So that also you can fill up. Otherwise, there is this page which comes up now, which says what is endangered by the current landslide. And you can say, okay, buildings, industrials. So whatever is applicable, you just click on that. So that will give you you will be submitting information regarding the casualty figures as well as what is likely to be damaged. Okay. And we come to the last page in this particular thing where we can go to the last page, which is this report and additional information you can give. Like I said in the earlier case, if you've got any information which is not appropriate, you can use it to fill up here in this, and you have to type it out in text. So that comes in the details. Just 1 second. Right. Right. So that is the last page, which is called the details. And this is where you can fill up any other information that you want to. And there are 2 check boxes at the bottom. It is okay for you to contact me if there's any clarification. If you don't want to report your name and all that, you can do that and you can submit it. You've now completed the entire the landslide reporting in level 1. Okay. If at all you have not completed, you can always go back and go and complete it at the back. I will tell you how to do that a little later. Okay. So now you are here. You can go back to your old. And now if you click on this particular thing that we have put a red circle and the three bars are there, you will come to this page. This page will come down. This drop-down menu will come down. Okay. And my drop-down menu is slightly different from yours because I'm a team admin. Yours will be member. Okay. But you're reporting on landslide tracker level 1. And you will have these drop-down menus. And if you click on any of these things, you will see additional pages will open. Okay. So view landslides will mean all the landslides which are available in the tracker. Okay. Landslides for approval, we will come to that a little later. But if you look at my landslides, then those are the landslides which you have put up. You can have a look and you can, when you click on my landslides, the screen on the right-hand side will be there, which will show you the landslides which you have reported. Okay. That will show you Darjeeling so-and-so, so-and-so, so-and-so. And if you click here on this, you will get the same information in terms of text. Okay. You will get the entire thing in terms of text. You click on any landslide that you want. You can go and edit the landslide which you've submitted. Mark your mind. Please understand that in the photograph, you can add photographs, you can remove photographs, etc. But the landslide which you have submitted, you cannot delete. So that is there. Okay. And further down, if you go, you can go into this page. This particular page is for me. Your page in this particular case, when you click here, would be much simpler than this. It will have report landslides, view landslides, landslides. Well, right now you won't have this thing. You will have my landslides. You will have translation where you can click and see the Nepali or the other versions, and additional information, PDF files which are there about landslides, what Nima talked about will be there, etc. Okay, so all this information will be there, and that is level 1 landslide tracker for you. I have finished. If you've got any time and if you want to ask questions, we can ask it a little later. From my side, I have finished my presentation. I will now ask Dr. Vishwanath to kindly carry on. As such, we are running a little late. Vish, over to you.
Yes. Thank you very much, Wing Commander Praful Rao. At the very outset, I would like to greet you all and convey my gratitude to Dr. B.B. Gurung, Kalimpong, the Science, the network, the Science Center, as well as Wing Commander Praful Rao, as well as Dr. Nima Lama, for having given an opportunity to be part of this group in sharing our thoughts and experiences on not only on landslides, but also on landslide documentation. So thank you very much, Dr. Gurung, Wing Commander Praful Rao, and Dr. Nima Lama. Would you allow me to share my screen?
Yes, sir. Please, sir.
Yeah.
Yes, sir. Please.
Well, the system doesn't allow me to share the screen. Presentation will briefly discuss the context, the project landscape, its aims, consortium partners. What do we mean by regional landslide early warning system? And then we go into crowdsourcing, which is what we have been doing from the community. That's what you've been contributing as landslide documenter or tracker. And then we finally go into the need for data improvement. The context, I think I wouldn't skip this context because already my colleagues have dealt with the context in terms of landslides, their significance in the northeast as well as in the mountain areas of the Himalayas. So the landslip is a project which is being implemented for the last 4 years. It's in the last year of implementation. It is a UK funded research project, a multi-country, multi-stakeholder research project. I'll come into the consortium, the composition in a short while. The aim is to develop a prototype regional landslide early warning system. We want to develop a prototype which will be further developed by Geological Survey of India, GSI. The pilot areas are Darjeeling as well as the Nilgiris in Tamil Nadu, two different geological geo areas. So the project aims to combine three major dynamics. One is the meteorological dynamics, like for example, the weather pattern, weather forecasting. Two is the landscape dynamics, which involves the landslide susceptibility, which areas are susceptible to landslide, as well as the landslide which have already been documented in the past. All this to combined towards probabilistic forecasting of landslide, and of course the social dynamics. Where are the institutions which govern disaster management located? How efficient these are, and what is the vulnerability of the people living in landslide prone areas. So I was talking about the three dynamics: meteorological dynamics, the landscape dynamics, and also social and cultural dynamics. Now, it's just not enough to develop a landslide early warning system. It's important that a format is developed for conveying this early warning system from the GSI to the district level, from the district level down to the block level, and then to the panchayats and others. So this needs to be disseminated through the fastest means. So I was already mentioning to you about the case study areas, and then Save the Hills in Darjeeling and Keystone Foundation in the Nilgiris are two important field partners in this project. So I'm showing you the slide relating to the prototype of regional early warning system. So the inputs are the observations in terms of precipitation, in terms of temperature, in terms of soil moisture, etc. And then you have the forecast. Like, for example, for the weather, we have the forecast, what we call weather pattern, which is again new science which has been developed by the UK Met Office. And then we have the maps: landslide susceptibility, landslide inventories, landslides which have occurred in the past. All these help to develop certain models which are based on the rainfall threshold and other information. All this results in decision support. And then you have the landslide early warning bulletins, which is issued every day at 2 o'clock or so during the entire monsoon. Whether you have landslides or not, this landslide early warning bulletin is being issued by the Geological Survey of India. So you see the consortium here, which consists of British Geological Survey, the King's College London, UK, the UK Met Office, which is the government department of UK as far as meteorology is concerned, and then an organization called CNR, which is a global organization working in the field of landslides and geology, based in Italy, Practical Action India, as well as UK. I belong to Practical Action, Newcastle University, and India, of course, led by Geological Survey of India, Amrita Vishwa Vidyapeetham University, and of course I mentioned to you about the two field organizations, Save the Hills and the Keystone Foundation. We have an external advisory board, one of which is Professor Vinod Menon, who is a founder member of National Disaster Management Authority, NDMA. So we were talking about the regional landslide early warning system. So what do we say regional? The regional means we are trying to develop early warning system for a region as a whole. This region could be 5 by 5 kilometers or 10 by 10 kilometers or so, and it's not slope. We are not going to develop kind of early warning system for individual slopes. That will be I'm not saying that that's not relevant. That could be relevant, but then it's going to be very expensive. But then we are talking in terms of a regional early warning system. For example, if you're talking about Darjeeling district, so within Darjeeling district, for an area of say 10 by 10 kilometers or 5 by 5 kilometers, developing early warning systems, forecasting landslides. So we can't really, under this system, forecast this particular slope is failed or this other particular slope is going to fail. No, all that one can say with a reasonable accuracy is that within this 5 by 5 kilometers or 10 by 10 kilometers, landslide could occur in big numbers or in medium numbers or in small numbers in the next 24 hours, next 48 hours, or could be in the next 15 days or so. That is the regional early warning system. So here the forecasts are based largely on the trigger. The trigger here is potential rainfall. So I mentioned to you about the weather pattern, which is a new science which UK Met Office has come out with, and the whole project is also based on that weather pattern, the scientific outputs. So what a regional level landslide early warning system can do, vis-a-vis the slope level, the regional level, the early warning system provides you a longer lead time so that the decision makers are prepared and be forewarned, because it is linked to weather forecasting and weather patterns, and it can give a heads up. For example, several days in advance, you will know whether that particular region is going to witness a high number of landslides or not. And it's also scalable at the national level. Like, for example, in India, there are 60,000 slopes where landslides can occur. So we can't really set up a landslide early warning system for each of the slopes. That is the reason why the regional level landslide early warning system has been developed. What it cannot do, it cannot provide fine resolution. It cannot say the landslide is going to occur in this village or the group of village. It is possible that we do this maybe in 4 or 5 years' time, not at this point of time. That means the system cannot forecast the failure of a particular slope, but it can forecast that a number of landslides can occur in this 5 by 5 square kilometer area. And now we talk about, I talked about the model, and then these models have to be refined. And these are scientific models which are refined and validated. And how are they validated? Because we need to continuously monitor landslides and then see how the bulletins relate to the actual occurrence of the landslide. Like, for example, I have received a bulletin as a district officer today, but I also need to know whether this bulletin, whatever that bulletin contains in terms of forecast, is going to be actually occurring or not. So for that, it's important that all the, or at least most of the landslides will have to be recorded, tracked, and documented to refine this system. Kind of, there is no limit up to which this can be refined. But I think we want to at least, kind of help GSI to, take this forward, and the GSI from next year onwards will keep, kind of documenting these landslides, not only through the state government, but also through the volunteers, through the NGOs, civil society organizations, etc. And that's what we call it in terms of crowdsourcing. And Dr. Nima Lama, as well as Wing Commander Praful Rao, had mentioned about the contribution that the hazard alert application is making. We also talked about the app which has been developed by Landslide. In fact, the software has been developed, the concept and software by Amrita University, and then the content has been developed by the Landslide group of scientists, including those from Amrita as well as from the GSI. Now, this is a cooperative effort of all the landslide partners to evolve a kind of a uniform methodology for tracking of landslides. And towards this end, the group, for over the last almost about 2 years or so, worked systematically to develop a paper format and a mirror, that is, kind of the app which has also been developed. Because some people may be hesitant to use the app, and then you have the paper format, and most of us may be comfortable with the mobile application, and then that can also be recorded. So both these contents, both the paper format as well as the mobile format, do contain the various guidance material. Like, for example, how do you observe the landslide? How do you document the landslide? What sorts of safety precautions you need to take while you document and track the landslide? So, and we are living through the COVID times. So, in documenting the landslides, how do you respect the COVID-19 local protocols and safety guidelines? So this is not something which is extremely new. No, not really. GSI already had a 12-point landslide information sheet and about a 42-point geoparametric reporting by the geologists and all that. So this is an improvement of the information that's already available with GSI in terms of how people could track the landslide, and then mobile application has also been developed. And then you will see that this reporting format is uniform, whether it is the government official or the civil society organization or a volunteer or anybody who's interested in contributing to landslide documentation. This format is more or less uniform, and it really helps the communities, especially those who want to ensure that they would like to contribute to mitigation of landslides in future and then help in early warning systems. They can also contribute. And then this, of course, as I said, includes the rainfall data also. So what you're seeing on the screen is the India Landslide Tracker form, which has been developed by this Landslide project, also with engagement of Save the Hills and also professionals like Dr. Nima Lama and others. So you have a form uh, and a similar kind of form is available in the mobile application. I just wanted to show you the paper format, which also has certain illustrations. How do you kind of, if you want to classify the landslide, whether the material is a rock or earth or debris, what is the size? So already we heard from Wing Commander Praful Rao that if you want to indicate the size, the size of the slide, best thing is to show in the background a person standing or a car or a truck or something like that, so that a person looking at the photograph has an idea of the size of the landslide. Of course, taking into consideration all the safety measures that one would need to take while recording and tracking landslide. And then I mentioned about the safety information, what are the do's and don'ts of recording landslides, and then you have certain additional information, some training material, awareness material, etc. How do I, where do I go in? Kind of whom do I consult if I want to know more about landslides? Because if I have recorded maybe 20 landslides, I would want to know more about the landslide. I would want to improve my own knowledge and information about the landslides. So a provision has been made towards this also. So one can also move, like for example, in the application, we mentioned about the 3 level. I can move from level 1 to level 2. And then if I'm proficient, I can move from level 2 to level 3 in terms of recording and tracking landslides. Now, this landslide early warning systems, the prototype was launched in the year 2020, during the monsoon of 2020. Now, we have managed to evaluate the 2020 landslide early warning bulletins and how they relate to actual occurrence of the landslides. We found both in Nilgiris and in Darjeeling, more than about 70% of the bulletin, the forecast came true. So we need to constantly work on refining this methodology so that we have a model which has a very high element of accuracy. And while collecting and documenting the tracking of the landslides, especially through the civil society representatives, volunteers, students, etc., we observe that even if one manages to track a large number of landslides, until and unless certain very crucial information are collected, the whole information about the landslide goes waste. So we also kind of have prioritized about 4 or 5 points which are a must for any landslide data collection. Like for example, the latitude and the longitude. Of course, if you use the mobile application, latitude and the longitude automatically gets recorded. But if you use only the paper format, then I think it's important to record the exact location of the landslide in terms of which village, panchayat, where, which road, near which landmark, etc., etc. And then this one point. The second point is landslide occurrence date and time. Even if we are not in a position to record the time, it doesn't matter. But date is extremely important because without the actual date, this information becomes infructuous and it becomes insignificant. So if you want to really record the landslide, I think the latitude, the longitude, the exact location of the landslide, the date, and if possible, the time of the landslide, the size and the impact. Of course, what kind of impact the landslide has caused. Maybe it's resulted in the death of a few people or injuries to the few people. The buildings have been damaged, etc., etc. And I think very important to have some good, sharp pictures of landslide. Like for example, for each landslide, we would advocate a minimum of 2 photographs, preferably with something in the background, so that it gives visually an idea of the landslide. Like for example, if you have a bus passing through a landslide and then looking at the bus, you will know that the landslide has been 3 or 4 times the size of the bus. So it really shows the scale. So I will stop here And thank you for giving me an opportunity. If you wish, I can share with you the presentation so that you can also share this with others and go through at leisure. I would also welcome questions and comments. And you need further information, please contact Wing Commander Praful Rao or me or any of the landslip scientists. For your information, the Landslip Consortium is led by two. The lead is there are two people. One is Professor Malamud, other is Miss Emma B. So I'd like to again thank Dr. Gurung as well as Wing Commander Praful Rao for having given me this opportunity to share with you a few thoughts on the Landslip project. Thank you. Over to Wing Commander Praful Rao or Dr. B. Guru.
Yes, sir. Thank you, sir, for your wonderful presentation, sir. And I request participant to raise a hand if you have any questions. You may ask the questions to the expert. Sir, there is one question from one participant. His name is Mr. Anand Rai. Sir, can we have some type of classes to learn more about landslide? Sir, it is there in the chat box, sir. So it is written. It is there in the chat box, sir.
Okay. Chat box. I'm not sure. Yeah, there's a chat box.
I can read it out. Can we have some type of classes to learn more about landslides? That's a question.
Absolutely, there's no doubt about this. We could do this with Dr. Nima's help. Also, Project Landslip itself is organizing videos and PDF files are already available there about landslides. But I'm glad that you asked. Your good name I'm not able to get. Anand Rai. Yeah.
Mr. Anand Rai.
Anand Nani, this information is already there. If you go to the app, PDF files are already there. But otherwise, Project Landslip will be adding videos, etc., to the Landslide app, so you can see it. But otherwise, most welcome. You can contact us or you can contact Dr. B.B. Gurung, and we have already talked about extending this type of projects further so that we are made aware. But I would like interested young people, especially from the hills, to attend these lectures, which are meant for landslide affected areas. I often see that the people are not interested one bit. I'm sorry to say about this. Thank you so much.
Any question from anyone? Any question?
Can I, if there are no questions, can I just take a moment, Dr. B.B. Guru?
Yes, sir. Thank you. Okay, sir. Okay, sir.
If I may just take 2 minutes, I would just like to spend 2 minutes to just thank everybody who's attended. Number one, thank you so much for spending your time with us. And I hope you learned something about landslides. And do download the app. I will leave my phone number here. do contact me or anyone, whoever is participating here, Dr. Nima, and so on. But you're most welcome to contact us. We would love to help you out as far as landslides are concerned, because we are from this area. We are from the hills. Landslides affect us. We've still got 2 months of rain left. Okay, so it is important for us to know about this. Number one. Number two is that I would like to thank Project Landslip for this developing this app, which is so great to have. You see, there are many apps which are there for disaster management. You look up Google Play and you can download many apps which are there for a whole host of disaster management related subjects. But this is the only app meant exclusively for landslides. And I'm so happy that Project Landslip has developed this app for us. Thank you, Project Landslip. I would like to thank Dr. Nima Domalama for always helping out and joining in whenever I require her help. And of course, to wish my good friend for wish long after Project Landslip is over, I will still continue to tap you for your help. My thanks to Dr. B.B. Gurung for this initiative. And like you said, Bhai, we should take this forward and do many more programs like this for people like Mr. Anand Rai. Thank you so much.
Thank you so much for this wonderful session, sir. On behalf of Kalimpong Science Center, I would like to thank Dr. K.R. Viswanathan, Dr. Nima Doma Lama, and Wing Commandant Prafulla Rao very much. From this session, we got an opportunity to understand landscape hazard and its benefit to report landslide and its technicality behind its development, etc. Hope everyone present in this program has benefited a lot. On behalf of all the participants, I would like to thank you very much. We look forward to hearing from you all in future too. We'll always be grateful for your invaluable time and knowledge. Once again, thank you so much. Thank you so much. All the today's resource person and all the participants. Thank you